Good morning, students. This is Niranjan Reddy, Assistant Professor, Mechanical Department, BITS Varangal. Today we'll see a problem on force systems. So here you can see forces are acting at a point O in different directions. So in this we'll find the resultant force, direction and angle from the x-axis. So first of all, when different forces are acting from one point at a point, so they are called concurrent forces. When forces are acting from different points, then they are non-concurrent forces. And when the forces are acting in one plane, then it is called coplanar forces. When forces are acting in different planes, then they are called non-coplanar forces. So in the problem you can see 4 different forces are acting at a point O, and in this we are asked to find resultant force and angle and the direction. So we can solve this problem in 2 methods. So one is, first we have to take the angle of this force, and for this force we have to consider from here, and for the third force we have to consider from x-axis and we have to take the total angle, and for this force 100 newtons we have to consider from here and we have to consider all this angle. So in this method, so we are taking sigma fx 0. So this means we are taking equilibrium of forces in x direction. So from this method, so the force, first force 200 newtons into cos 45 degrees, and for this 120 is the force into cos 125 degrees. So this angle is from here, so this is 90 and this is 35, so 125 degrees. So like that. For the next force, 50 into cos 240 degrees. So from here to here, and for the next force 100 into cos from here to here 300 degrees. So when we solve this one, so these are the values 141, 68, 20, minus 25 plus 50. So this will be 97.591 newtons. And if we sigma Fy is equal to 0, so resolving the forces in y direction, so this will be 200 into first force into sine 45 degrees. So for this resolving in y direction, sigma Fy is equal to 0. So for this method also, in this equation also, the angles are same. In the same method we will consider. So 120 into sine 125 degrees plus 50 is the force, 50 newtons, into sine 240 degrees plus 100 is the force into sine 300 degrees. So when I solve this one, 141 plus 98.298 minus 43 minus 86.602. So when I solve this, 109.815 newtons. So we got forces in x and y direction, and the resultant force is under root of fx squared plus fy squared. So when we substitute those two values in this equation, so we'll get, so this one 146.912 newtons. To find out the angle, we'll use this formula. Tan theta is equal to ry divided by rx. So the resultant forces in y direction and x direction. So we got here the resultant force in x direction 97.591 and the resultant force in y direction 109.815 newtons. So when I substitute these values in this equation, theta is equal to tan inverse of this one. So when I solve this one, I got 48.366 degrees. So this is a simple problem in force systems. So this is one method to solve resultant force and direction and angle from this axis, x axis. And another method is, so take x component and y component of this force for all the forces 1, 2, 3, 4, for all the forces, and then take equilibrium of x and y, so that we can find resultant forces in x and y direction, and the final resultant force is by this method. So the method is almost same, but so in this method we are summing up all the angles, but whereas in the second method we will directly take these angles. So 45 degrees from this axis, 55 degrees from this axis, 30 degrees from this axis, 60 degrees from this axis. So like that you consider angles and forces in x and y directions. So that I will post in that I have already posted in my channel images regarding second method. So this is brief about the problem. This is the solution method one of the problem. So we'll meet with another topic in the coming class. Thank you. Please do like, share and subscribe my channel.